All right, so get this. You sent in some fascinating research about the hunt for dark matter, and it turns out scientists are using a brand new technique to try and track this stuff down.
Hmm. Interesting.
Yeah, it's wild. So it all revolves around this mystery. We know there's way more maps in the universe than we can actually see.
We're talking about dark matter, right? It's like the ultimate cosmic ghost story.
Right.
We can't see it, we can't touch it,
Nope.
but we know it's out there because of the way it affects everything around it.
It's kind of freaky, right? Like, what is this stuff? What is this stuff that's literally holding galaxies together?
Yeah.
And how do we even begin to search for something that's invisible? The article you sent in mentions some new research from Tokyo Metropolitan University,
Okay.
published in Physical Review Letters on February 7th of this year,
Yeah.
using the Magellan Clay Telescope in Chile.
Oh.
They were looking for evidence of something called Axion-like particles.
Mm.
Have you ever heard of these things?
Oh, yeah. Axion-like particles, or ALPs, are a hot topic in the dark matter world right now.
Right. Okay.
They're these theoretical particles, meaning we haven't actually observed them yet.
Right.
But if they exist, they could be a major component of dark matter.
Okay, so they're like the prime suspects in this cosmic whodunit.
Exactly.
But how do we even begin to look for them?
Well, the researchers in this study are using a pretty clever method called infrared spectroscopy.
Okay.
Imagine you're looking at a rainbow that's the visible light spectrum,
Okay.
but beyond red, there's a whole range of light we can't see with our eyes, infrared light.
Oh, right, like the heat vision cameras in spy movies.
Exactly. Now, some theoretical models suggest that if these ALPs exist, they might decay over time and emit light in this infrared part of the spectrum.
Yeah.
It's like each type of particle has its own unique fingerprint in the infrared.
Oh, wow.
So the scientists are essentially looking for these fingerprints.
So they're scanning the sky with this infrared microscope looking for signs of these ALPs.
Yeah.
That makes sense, but I'm guessing it's not as easy as it sounds.
Yet one of the biggest challenges is that the infrared spectrum is incredibly noisy.
Ah, I see.
There's a lot of interference from things like zodiacal light, which is just sunlight scattering off dust,
Okay.
or even the Earth's atmosphere itself, which glows in infrared. So trying to find a faint signal from dark matter against all that background noise is like trying to hear a whisper in a rock concert.
Okay, yeah, that sounds tough. But the article mentioned a specific instrument on the Magellan Clay Telescope called WINERD.
Yes,
I'm guessing this has something to do with solving that problem.
absolutely. What's so cool about WINERD is that it doesn't just detect infrared light. It actually analyzes the specific properties of that light.
Oh, okay.
So instead of just seeing a jumble of infrared signals, it can pick out subtle differences in the way that light is emitted.
So it's not just seeing the colors, it's like understanding the texture or the pattern of the light.
That's a great way to put it. Imagine you're listening to an orchestra.
Okay.
You can hear all the instruments playing together, but it's hard to pick out individual melodies. WINERD is like having a conductor who can isolate the sound of a single violin amidst all the other instruments.
Wow, okay, I'm starting to get the picture. So by analyzing the infrared light in this way, they can filter out the noise and potentially spot the unique fingerprint of those ALPs.
Precisely. It's an incredibly sensitive instrument that allows them to search for these faint signals from dark matter with much greater accuracy than ever before. Now, for this particular study, they focused on two dwarf galaxies, Leo V and Tucana II.
Dwarf galaxies, why those?
Remember how we talked about dark matter holding galaxies together?
Yes.
Dwarf galaxies are thought to be especially rich in dark matter.
Hmm.
They have a much higher ratio of dark matter to visible matter compared to larger galaxies like our own Milky Way.
Oh, I see. So it's like they're zooming in on areas where they think the dark matter signal might be strongest.
Exactly. And these dwarf galaxies are millions of light years away,
Oh.
which means the light we're seeing from them has been traveling for millions of years. It's like we're looking back in time.
So what did they find? Did they actually manage to detect these ALPs?
Well, it wasn't quite a slam dunk. After 4 hours of observation, they didn't get a clear signal of decaying ALPs.
That's kind of a bummer. Does that mean the whole thing was a bust?
Not at all. Even though they didn't find a direct signal, this null result is actually incredibly valuable. Think of it like this. Imagine you're searching for a lost treasure.
Okay.
You spend hours digging in one spot and you come up empty.
Right.
That might feel like a setback, but you've actually learned something important. You've eliminated one possibility, and now you can focus your search elsewhere.
Okay, so even a no gets us closer to a yes in the world of science.
Exactly. In this case, the researchers were able to set new limits on the lifetime of these ALPs. Basically, they were able to say, okay, if these particles exist, they can't last for longer than X amount of time before decaying.
Mm-hmm.
That information helps us refine our theoretical models and narrow down the possibilities.
So they're tightening the net, so to speak, closing in on the true nature of dark matter.
Right. But here's where it gets even more interesting. While they didn't find a clear signal, they did observe some slight anomalies in the data.
Anomalies? What do you mean by that?
Well, remember how we talked about Weinert being able to pick out subtle patterns in infrared light?
Yeah.
They found a few instances where there was a bit more light than they expected in certain parts of the spectrum. It wasn't enough to definitively say, hey, that's an ALP, but it was definitely intriguing.
Ooh. So maybe a little flicker of something unusual? Like a faint echo from the dark side of the universe?
Maybe. It's definitely something they're going to follow up on.
Yeah.
It could just be a fluke, some kind of instrumental error or background noise they haven't accounted for. But it's also possible that it's a hint of something truly revolutionary.
Okay, so even though they didn't get a definitive detection, there's still a lot of excitement around this research. What makes it so groundbreaking, even without that eureka moment?
Well, for one thing, it demonstrates the incredible potential of this new method, infrared spectroscopy. Remember, we're talking about looking for a whisper in a hurricane. And this technique gives us the tools to actually hear that whisper.
And the fact that they're targeting these dwarf galaxies, those dark matter-rich environments, is another game changer, right?
Absolutely. It's all about maximizing our chances of finding those elusive particles.
So let's imagine for a second that future observations do confirm the existence of ALPs or some other dark matter candidate. What would that mean for our understanding of the universe?
Well, on one level, it would finally solve one of the biggest mysteries in cosmology. We'd know what this invisible stuff is that's been shaping the universe for billions of years. It would be a monumental achievement, like filling in a huge blank spot on the map of the cosmos.
But wouldn't it also open up a whole new set of questions?
Of course. And that's what makes it so exciting. Imagine we finally discover this whole new realm of the universe made of particles and forces we never even knew existed. It would completely change our understanding of physics, cosmology, maybe even the nature of reality itself.
That's kind of mind-boggling. And you know, it's funny because we started by talking about something invisible, something almost impossible to grasp. But the more we dig into it, the more I realize how fundamentally connected it is to everything we see and experience in the universe.
It's true. Dark matter might be invisible, but its influence is everywhere. It's the scaffolding that holds galaxies together, the hidden hand that guides the evolution of the cosmos. And understanding it could unlock secrets we haven't even begun to imagine.
It's a pretty wild thought, isn't it? That the answers to some of the biggest questions in science might be lurking right under our noses, so to speak, just waiting to be discovered.
Absolutely. And you know what else is exciting? This is just the beginning. The team behind this research is already planning follow-up observations with even more sensitive instruments. They're targeting other dwarf galaxies, looking for more of those tantalizing anomalies. It's a rapidly evolving field, and who knows what breakthroughs might be just around the corner.
It feels like we're on the cusp of something big. It's making me think about the early days of astronomy when people first started turning telescopes toward the sky and realizing just how much was out there.
I think that's a great comparison. We're entering a new era of exploration, a time when we're starting to peer into the darkest corners of the universe. And I, for one, can't wait to see what we discover.
This is why I love these deep dives. They remind us that even in a world that feels increasingly familiar, there's still so much out there that's unknown, so much left to explore.
And the best part is we don't have to be scientists or astronomers to be a part of this journey of discovery. Anyone can follow along, read the research, and share in the excitement.
So what would you say to someone who's listening to this right now and feeling inspired to learn more about dark matter? Where should they start?
Well, there are some incredible resources available online. Websites like NASA's website or the European Space Agency's website have tons of information on dark matter, Axionlike particles, and the research being done to uncover its secrets. And there are some fantastic YouTube channels that break down complex scientific concepts in a really engaging way.
It's amazing, right? We started talking about this invisible thing called dark matter, and now we're talking about YouTube channels and websites.
I know, it's true.
Yeah.
And I think that accessibility is really important. Science should not be locked away in ivory towers.
Yeah.
It belongs to everyone.
Absolutely. But I have to admit, sometimes I hear about these big scientific discoveries and I think, that's amazing, but what does it actually have to do with me?
Right.
Like, will understanding dark matter change my daily life?
That's a fair question, and I think the answer is maybe not directly, at least not right away, but The pursuit of knowledge for its own sake is one of the most rewarding things we can do as humans. It's what drives us to explore, to innovate, to make sense of the world around us.
Right. Yeah.
Yeah.
Oh, okay, I get that. But wouldn't it be cool if it did lead to some kind of practical application? Like, imagine if figuring out dark matter led to some new technology that changed the world.
You never know. Think about it. 100 years ago, no one could have predicted how discoveries in quantum mechanics would lead to things like smartphones and the internet. Understanding the fundamental nature of the universe often lays the groundwork for incredible technological advancements down the road.
So even if we don't see immediate results, studying dark matter could plant the seeds for future innovations that we can't even imagine yet.
Exactly. But even beyond potential technological applications, there's a deeper level to this. Understanding dark matter fundamentally changes the way we see the universe and our place within it. Right now, we're essentially blind to 85% of the matter out there. It's like we're trying to read a book with most of the pages missing.
Wow, and finding those missing pages could reveal a whole new story, right?
Precisely. Imagine what we might discover if we could suddenly see all that dark matter. It could reveal new galaxies, new structures, maybe even new laws of physics. It's like opening our eyes to a whole new reality.
I love that idea, a whole new reality just waiting to be discovered. It makes me think of that Carl Sagan quote, "Somewhere, something incredible is waiting to be known."
He was absolutely right, and the search for dark matter is a perfect example of that. We're pushing the boundaries of knowledge, venturing into the unknown, and who knows what amazing discoveries await us.
This deep dive has certainly been a journey into the unknown for me. I feel like I've learned so much, not just about dark matter, but about the scientific process itself, the curiosity and the determination that drives it.
And remember, this is an ongoing story. The research we've discussed today is just one chapter. New discoveries are being made all the time, and it's a field that's constantly evolving.
So if someone wants to keep following along with this cosmic adventure, what would you recommend?
Stay curious. Keep reading articles, watching documentaries, and exploring the incredible resources available online. There are so many ways to engage with this topic.
Well said, and I think that's a great note to end on. Thank you so much for taking us on this incredible deep dive into the world of dark matter. It's been an eye-opening experience.
My pleasure. And to our listeners, keep those questions coming, keep exploring, and never stop wondering about the mysteries of the universe. Who knows, maybe you'll be the one to make the next big discovery.